Okay, so does it show growth or decay? And the number, the base number tells you whether it's growth or decay. Less than 1, that's decay. What is the rate of growth or decay? Well, if it's decay, you do 1 minus whatever that number less than 1 is. So 1 minus 0.57 is 0.43, or you could say a 43% rate of decay. What's the initial value? Well, that's always what you put in, the 35. And then evaluate for t, you would just do 35.057 to the 5th power if t is 5. Plug that into Desmos or your calculator, not 0.057, 0.57 to the 5th, and you should have got 2.11, it looks like. Like I said, this is just calculator work, so. Next one. The 1.23 is bigger than 1, so that should be growth. If that tells you whether it's growth or decay. What is the rate? Well, since it's above 1, you do 1.23 minus 1, which would leave you the 0.23 or 23% growth rate. The initial value is the 225. And to evaluate for 7, right, 225 times 1.23 to the 7th power. 1.23 to the 7th. 958.34. 958.34. Questions so far on any of that? All right. So I'm going to, well, compounded, the formula is how much you put in. They said that the 500, the principal, 500 for A. 1 plus, compounding is increasing. Your rate as a decimal would be 0.0365. Right, you move it twice. Over, since it's compounded, annually is once, which over 1 isn't going to change anything, and then 1 times t would be the power. So that's the function. So each one of these, they don't change, it's just 0.0365, just how many times you compound. If it's quarterly, it'd be 4 and 4t. So that changes 2 numbers when it changes compounding. Monthly, 1 plus 0.0365. Monthly is 12 times a year, 12t. And weekly is 52. That'll be 03. And there was nothing to evaluate here, just writing the functions. 52 times a year for weekly, so 52t. Where t is the number of years. So if it's compounding and it gives you a set number of times that it compounds, you use that fractions. But if it is compounding continuously, they don't give you a set number, then it's a whole different formula. So continuously, 6.2, your continuous is P e to the RT power. So the first one for 5 years would be the 808. E, the rate is 0.062 times 5 years. So to put that in your calculator or in Desmos 808. You just type the e to the power of, make sure that 0.062 times 5 stays in the exponent. In Desmos, you might need to put parentheses around it to keep it all in the, but you should get 1101.65. And the only difference is changing this 5 in each one of these to a new year. So if I change that to 10, it's 1502.01. Change it to 18, 2466.52. And change it to 25, 3806.87. So yeah, you're just changing that time. Everything else would stay for those. All right, so this is where I want to set it up. I'm not necessarily going to get the answer each time. I think you guys can put it in the calculator. Ryan is saving for college tuition. He's got $2,550 in a savings account that pays. So if he's saving for college tuition, he's wanting his money to increase. So this is growing. That paying is they are paying him. So if he starts out with 2,550 and it's 1 plus, because you want that money to grow to save, 0.625 to the t power, because it doesn't say how many years for the equation, right? So a equals, now for 6 years, just plug 6 in for t and you can get the how much it's worth. That you're just gonna have to grab a calculator and do. So write an exponential equation that describes this situation. A used car purchased for that much is decreases. So this is decay. So it starts at 12,329. It is 1 minus 8.5% is 0.085. And again, to the t power. Now, if it was purchased this year, which is 2020, and they want to know what it's worth in 2026, you just have to subtract those. That would be 6. So you would plug 6 in for t because it's 6 years later. And that'll give you that answer. Stop me if you have questions. Hopefully so far so good on what you did. He owns a business. The first year he made that. Each of the following years his profit increased. So this is growth by 12%. So it started at 11,212. It is growing 1 plus 12%, 0.12 for t years, and then plug the 20 in. That one's not too bad. Just bought a home. She paid that much. She's able to pay 20%. So she's wanting this value, right? She had a loan. This is how much she owes the bank, and she's paying off the loan. So she wants that to decrease. So she starts out owing 240,000, and she's going to make it decrease by 20% as 0.20 each year. So your t is in years. 10 years, plug that 10 in. Okay, so these are the ones you have to be careful about. When a bacteria doubles in number every hour, if there are 20 bacteria now, how many will there be in 7 hours? It's important that those two have the same units. And they do, so this one's not a big deal. So you start with 20 for A. When it doubles, you don't add or subtract, you just 2 is your base for doubling. And it would double for 7 hours because it's every hour, 7 hours. You can just plug that into the calculator. The number of mosquitoes is tripling every month. They start out with 852 mosquitoes. I don't know how they counted them, but they did. Tripling is 3, and every month. So how many will there be in 3 months? To the third power. And then you can plug that in. But just when it says doubles or triples, that's your base. So if I ask you when it's doubling, what's the rate of growth when it doubles? Well, 2 minus 1 is 1. That's 100% growth when something doubles. If it triples, 3 minus 1, that's 200% growth when it triples. So, all right. There's really no need to give my family members my schedule because they're going to just call whenever they want to anyhow. All right. So I have 5,350,000 people, 1% annual decrease. What is the city's population after the following years? So that's 5,350,000. 1 minus 0.015 for your decimal, 1 year, and then that would be the same 5 years, 10 years, 15, but the setup doesn't change. And the number is going to get smaller and smaller and smaller. So that one should be easy. Just changing that decimal. Remember, if you're not sure, you can always take your percent and divide it by 100, and that will do it. 0.015. All right. Alan deposited into an account that earns 4% yearly compounded monthly. I made it bold so you'd remember. He didn't deposit anything else. What's it worth in 8 years? So how much he put in, 1 plus, and since it's compounded monthly, you need that fraction. 4% is 0.04 over monthly is 12 times per year. And then you do 12 times the number of years is 8. So when you put that into Desmos, just be careful. That'll change to a fraction when you hit the divide button. Make sure you're in the parentheses, raise it to a power, and put that in its own parentheses so everything stays in the exponent. So just to make sure, 1 plus 0.04 over 12 in your parentheses to the 12 times 8 power, you should get 1651.67. And the whole reason it says he didn't deposit anymore is because if he added money to the account during this time, that would change all of the interest and everything. So, and just make sure when you're compounding, this number should match that number. It'll always appear there twice. Question? Good so far? Somebody talking. Miss Bentley purchased a new car, and she plans to sell the car in 5 years. It's going to decline 7.5%. what's the value at the end of the loan? So the value of the car is going to decline. 1 minus 7.5% is 0.075, and her loan is for 5 years. Just plug that in. It's okay. All right, so Andy bought a PS5 for $499, although they just had a huge mishap of doing the pre-sale. For those, did not tell anybody when the pre-sale was going to start. So now we're waiting to get in on the new PS5. It's predicted the price will decline, so that's 1 minus 2.5%, 0.025 each year. If he decides to sell 2 years each year, make sure those match. So 2. She's saving money. It pays 3.5 yearly, compounded quarterly, 8 years, so it would be 1,600. 1 plus her rate, 0.035. Quarterly is 4 times a year, so you'd raise that to the 4 times 8 power. If you're getting ridiculous numbers at the end of these, just double check how you typed them in. If you're getting scientific notation, if you get something that is like 2.351472, then you see at the end it says E8, that's scientific notation, which you would just do 2.35 times 10 to the 8th, because sometimes the numbers get big. So if you see an E in your calculator, that means that it's being multiplied times 10 to the 8th would be 100 million times that number. And that's just too big for your calculator to handle, so it converts it. $15, you're doing that money, interest rate 4.15 for 10 years. What's the total amount? So 200, 1 plus 0.0415. So it doesn't matter how many numbers are after the decimal, just always move it twice for 10 years. Compounded weekly, $600, 6% for 5 years, or I mean $6,000. 1 plus, since it's compounded, it's that fraction, 0.06 over weekly is 52 times. So it'd be 52 times 5 years. All right, so 17 is the one I had to change. So now it's 300 in one account for 10 years, 3.5% compounded monthly. So 300, 1 plus 0.035 over monthly is 12 to the 12 times 10 years. And then the other one was $300, same percentage rate, but now compounded quarterly, 4 times a year, 4 times for 10 years. And it's just to compare which one is better. And what you should find out, it'll be slightly better, but the more times it's compounded, the better. So 12 would be better than 4 times a year, because you would get paid interest on your money 12 times over the year, where here you would get paid interest on the money just 4 times a year. So it'd be less interest that you get paid each time with 12, because your rate's being divided by 12, but in the end, it would be better. You should see that when you get done. Compounded daily for 5 years. How much money will be at the account? Oh, she invests, I don't know why that's 5 and 3, but at the end of 3 years, no matter how long she had it in there in the end, at 3 years, it'd be 1 plus 0.0325 divided by daily is 365. And that'd be 365 times 3 if you wanted the end of 3 years. This doesn't matter. Six years compounded annually. That's the one where if it's compounded annually, 1 plus, whether you do 0.05 over 1 to the 1 times 6 power, well, if it's annually, that's exactly what annual growth is, our normal one. You don't need those ones. It'd be the same thing. So either way, same answer. 6 of one, half dozen the other. Okay, so these are the ones starting with 20. These are the ones where you have to be careful. The rate is each month, but it wants to know population after 3 years. So you're starting with 250,000 mice, and they are decreasing 0.167, sorry, 0.0167. So your time here has to be months, right? But if they give you the value in years, you could do the math yourself and say that 3 years is 36 months, right? Or you could just put that math up there, right? So whether you use 36 or 12 times 3, or 36 months, right? Months in a year times, that will give you the answer. So if these two don't match, you need to make sure that what you're putting in your exponent matches whatever the rate is. Number of mosquitoes at the beach is increasing 12%, 1 plus 0.12, starting at 200 or 25,000 mosquitoes. And how many? So this is weekly. So this number is weeks. How many will there be tomorrow, which is 1 day? Right? So how do I change a week to 1 day? Well, you would divide by 7, right? So 1 day is 1/7 of a week. If you had 7 days divided by 7, that'd be 1 week. 14 days divided by 7, that would be 2 weeks. So if it's just 1 day, it's just 1/7 of a week. So if your rate in weeks and your time that you want is going to be less than that, you're going to need to divide. You have 500 earning 2.5% compounded daily, 365. So there are 365 days in a year times 30 years. That's just back to the regular compound. That one's not so bad. Just making sure you get those in your calculator. So this value is depreciating per month. How much will it be in 8 years? Since months are smaller than years, that's a multiply, right? So that would be 1 plus the, oh, it's depreciating. So it'd be 1 minus the rate, and it would be 12 times the number of years, right? So $32,000, 1 minus, the rate is already, so I still have to move it twice, so it'd be 0.0071 to the 12 times 8, because 96 months in 8 years. New house, it's depreciating every 5 years. So you have the $520,000 house. It's appreciating, so that's up. Appreciate means increase. 12%, 0.12. This has to be every 5 years. So how much will it be worth in 1 year? Well, 1 year would be 1/5 of every 5 years. How much will it be worth in 20 years? Well, 20 years is going to be how many 5-year periods, right? So that is 20 divided by 5, which would be 4, right? 4 5-year periods in 20 years. How much will it be worth in 32 years? 1 plus 0.12, that would be 32 divided by 5. So 6 2/5, a little more than 6 years. So that's how you would do, if it's every 5 years, just take the years, divide out the 5. All right. Each year, new computer per week, 1.38. How much will it be worth in 10 years? So this would be $1,500 computer. It loses value. So 1 minus, the rate is 0.138. And it's doing that every week. Well, in 10 years, that would be 52 weeks times 10. 1 minus 0.0138. How much will it be worth in 5 months, assuming that there are 4 weeks per month? So that would be 4 weeks per month times the number of months. How much would it be worth in 100 days? Well, days is less than weeks. So you'd end up doing the number of days divided by, there's 7 days in a week. So months, those are more than weeks, right? So you multiply, but when it went into days, you would divide. All right, so hopefully that helped you on this very last part. So looking at the equation, if t is years, like this function is growing at a rate of 12%, and if you are multiplying, right, years, if you have 12t, then if you took a year and divided it by 12, you would get a month. So what this is saying is that you would take the number of years, like if this was 1 year, multiplying it by 12 would turn it into months. So think of this unit of measure, and if it's being multiplied here, divide it up. If you take a year and divide it into 12 parts, those are months. If there is a fraction here, then multiply that unit of measure. Oh, if you took a year and divided it into 365 parts, you would get days. So this is decay. 1 minus 0.95 is 0.05. So that's 5% each day. Just in time. So when, like I said, when it is divide, you can multiply. So this is growth, right? When you subtract the 1, you would get 8.5%. And if you take seconds and multiply them by 60, right, that is a minute, right? 60 seconds makes 1 minute. So this is every minute. So in other words, if it said how many are there in 60 seconds, you do 60 divided, or in 1 second. No, in 60 seconds, 60 divided by 60 give you 1 minute. Well, I said that wrong. Finally said it right at the end. All right, months. If you took months and divide them into 30 parts, you would get days, approximately. So this is decay. 1 minus 0.88 is 0.12, so it's 12% each day. So this is hours, right? And if you have 24 hours, you get 1 day. So multiply, or think about if you had 24 of these, that's a day. So this is also decay. 1 minus 0.925 is 0.075. 7.5% decay. So that's growth. It is growing at 33.5%. If you have 60 months, so it's not a standard unit of time, but 60 months is every 5 years, right? Because you take your months and multiply the 60. That would be every 5 years. Again, decay. If you have a day and divide it by 24, that's an hour. And the rate is 0.003, which is 0.3%. That's it. So we shall